Hey guys, Mr. Rysz here to help you out to review for the final exam. So keep in mind at any time in this video, you guys can pause, rewind, but I'm going to go just straight through every single problem here. We'll talk about things that we've done and, making sure we can go through this. I'm also probably going to eat a snack along the way too. All right, so strap in, let's begin here. First two problems here, what we want to do is simplify each radical expression. So in order to do that, what we need to do here is to break down each number. See, 81 I think of as 9 times 9. 9 is 3 times 3, 3 and 3. All right, to break out of a fourth root, we need to have 3 of them, or not 4, we need to have 4 of them, and we have 4 3s. So one of them gets to break down, and there'd be nothing left over once it breaks out. Now, when it comes to variables, we could do the same thing, or we can just simply divide. If I have 20 A's, and I want to get groups of 4, 20 divided by 4 is 5. So we would have 5 groups of 4 A's that will work out. And then B's, if we have 36, 36 divided by 4 is 9. And so there's the answer. Okay, next here, 125 is 25 and 5. 25 is 5 and 5. So the cube root of 125 is just 5, because we need 3 of them to break out. And then we divide. We have 3 x's and we need 3 of them to break out. That means 1 can break out. Or we can just call that just plain old x if we want. And then 21 y's divided by 3, be 7 y's left over. Okay, let's keep this going. Got a lot of problems. We'll go through each one. Now, when it comes to evaluating a fraction with a radical in it, what we need to do is to multiply the top and bottom by the conjugate. So in order to do this, we need to multiply by 5 plus radical 2 to both the top and the bottom. All right, so the top we just distribute. All right, 4 times 5 is 20, and 4 times radical 2 is 4 radical 2. Excuse me, on the bottom, we need to distribute. So we got to do 5 times 5, which is 25, and then 5 times 2, radical 2 is 5 radical 2. Then we'll distribute the negative radical 2. Negative radical 2 times 5 is negative radical 2. And then negative radical 2 times radical 2 is negative radical 4. So what ends up happening, we get 20 plus 4 radical 2 over 25. Now, the plus 5 radical 2 and the minus, those are going to cancel out, and those will always cancel each other out. And basically, we have minus the square root of 4 is 2. So we got 20 plus 4 radical 2 over 23. The last thing we want to do is to see is, can we divide 24 and 23 by the same numbers? We can't, so we call it a day. That's it. All right, so let's repeat this process again over here. So we're going to multiply by 3 minus radical 7 on both the top and the bottom. All right, so the top here, we distribute. So 2 times 3 is 6, minus 2 times radical 7 is 2 radical 7. The bottom, we'll distribute here. 3 times 3 is 9, and then 3 times negative radical 7 is negative 3 radical 7. Radical 7 times 3 is a positive 3 radical 7. They cancel out. And then radical 7 times negative radical 7 is negative radical 49. So we get 6 minus 2 radical 7 over, this becomes 9. Those go away, cancel out, minus 7. So we got 6 minus 2 radical 7 over 2. So last thing we want to do is to see, can we divide 6, 2, and 2 by the same number? Yeah, we can divide them by 2. And so 6 divided by 2 is 3, and then 2 radical 7 divided by 2 is just 1 radical 7, or just radical 7. And there's the answer. It'd be 3 minus radical 7, which is crazy because that's the conjugate. It just worked out that way. All right, let's keep this going here. All right, next, if we're going to translate a graph, and we can always double check this on Desmos too, we want to make sure that we get this right. What we need to do, if we want to move to the left, we're going to go inside the function. So inside the function is this x. And remember, it's opposite thinking. So you think left is usually negative, but actually opposite, it'd be plus 6. But then outside, we're going to do the right thing. So to move it up 10, outside the radical, we're going to do plus 10. We can take a second, pull this on Desmos just to double check, but that's the answer. All right. Next, okay, we got the h, find the inverse equation. So remember, to find inverse equations, what we're going to do is we normally have y equals 5x plus 8. we're going to switch the x and y's around. So we got x equals 5y plus 8. We need to get this y by itself. So we'll minus 8 over, and we get x minus 8 equals 5y. We want to divide by 5 as well to get rid of that, and so we get x minus 8 over 5. We can just leave it like that because they don't divide. And once we get the y by itself, that's the inverse equation. So the inverse function is x minus 8 all over 5. Okay, remember you can watch this video, pause at any time, go back, see. All right, how do we solve radicals? Well, the first thing we want to do is isolate one of the radicals, which we already do. We have this isolated. We need to square. So we need to square both sides. Now, when we square this side, since it's not a single radical, we actually have to write it out twice and FOIL it. Now, what's nice about this one here, when we square the radical, and it cancels out the radical, and we just get 3x plus 10. Now over here, we need to distribute. So radical x plus 7 times radical x plus 7 is x plus 7. All right, then we would have a minus radical x plus 7. And then we'd have another minus radical x plus 7. And then negative 1 times negative 1 is a positive 1. Okay, so what we want to do now is let's put these two together here. So we have a negative 2 radical x plus 7. And then let's move this x over here to take away, so that's a 2x. And then we'll move the 7 and the 1 over. So a minus 7 will also minus 1. So we get plus 2. Okay, now what we need to do is repeat this process again. We're going to square both sides. When we square this, we get the negative radical, or negative 2 becomes 4, and the radical goes away. So this is 4 times x plus 7. And then over here, the 2x plus 2, we have to write out twice and FOIL it. All right, so we distribute the 4 here. We get 4x plus 28 equals, and if we FOIL this out, we get 4x squared plus 4x. And then distribute this one here, we get plus 4x plus 4. Man, a lot of 4s. Okay, now we have a quadratic problem. Quadratic problems, we're going to go ahead and move everything over, set it equal to 0. All right, so we got a 4x squared. We minus this 4x over, basically we can say that cancels out, and we're just left with the positive 4x. And then if we minus the 28 from the 4, that's a negative 24 equals 0. Now to solve this quadratic, we can do a lot of different things. Now the easiest thing I see here is, since we can divide all of these numbers by 4, let's do that. We get an x squared plus an 1x minus 6 equals 0. And we got to figure out what two numbers multiply together to give us negative 6, add together to get 1 in the middle. And that'd be 3 and negative 2. So we'd get an x plus 3 and an x minus 2. Meaning we get two answers here of x equals negative 3. Remember, after we factor, we set it equal to 0, or just name the opposites. And then an x equals 2. All right, and then the last thing we need to do with this problem here is to check, plug them in to see if they work. If we plug negative 3 in, negative 3, it would be the square root of, that would be 4 minus 1. Is that the same thing as the square root of, that would be negative 9, that'd be the square root of 1. So 2 minus 1, is that the same thing as 1? Yes, so negative 3 works. We should also double check, does positive 2 work? So if we plug that in, positive 2 would be 9. The square root of 9 minus 1, which is 3 minus 1, is that the same thing as, if we plug in 2, that'd be 6 plus 10, that'd be square root of 16. Is 3 minus 1 the same thing as 4? No, it is not. So only one answer works, and that's negative 3. Okay, we got another problem here, just to kind of practice, make sure we get these steps good. All right, let's go with these radicals. So we got one already isolated. We're going to square both sides. So this first part here, it just becomes a 2x plus 12. Now the other side, we do need to write it out twice and FOIL it. Okay, so we get a 2x plus 12. Now 2 times 2 is 4. 2 times radical is that 2 radical 4 plus x. And then radical 4 plus x is another same thing. And you guys can see that always happens. They repeat in the middle. And then the radical 4 plus x times radical 4 plus x is just a 4 plus x. Okay, so now let's combine these two together. So we get a 4 times radical 4 plus x. Let's not put my pen here. And let's move some things over. Let's move this x over away from this 2x, so that's just a 1x. And let's see, we have a 12 here. We would minus this 4 and minus that 4, and that's just a 4. Next thing, okay, let's get rid of the other radical by squaring both sides. And so we would have to write out the x plus 4 twice, and then we square. The 4 squared is 16, and the radical goes away. 16 times 4 plus x. Okay, if we FOIL this, x times x, that's x squared. X times 4 is 4x. 4 times x is also 4x. 4 times 4 is 16. And then if we distribute this 16 here, 16 times 4 is 64 plus 16x. All right, we have a quadratic. Any quadratic we should make equal 0. So we're going to have our x squared here, only one of them. We have a 4x and a 4x, and then we minus 16. So we got 8 minus 16. That's negative 8. And then we have 16 over here, but we'll subtract 16, and that would be a negative 48. Okay, so now it comes down to solving by factoring. What two numbers multiplied together give you negative 48? Add together to get negative 8. And that would be, let's think about it, that'd be negative 12 and positive 4. So we have an x minus 12 and an x plus 4 when we factor. And we solve each one of those, we get x equals positive 12 as a solution, or potentially, and then x equals negative 4 as another potential solution. And what we got to do is plug both of them back in to see if they work. So if we plug 12 in, 12 would be, okay, 2 times 12 is 24, and plus 12, that'd be 36. Is that equal to 2 plus the square root of 4 plus 12 is 16? Does 6 equal 2 plus 4? Yes, it does. So 12 works. All right, next, let's go through, let's plug in negative 4. So if we plug in negative 4, this would be negative 8 plus 12. That would be just 4. Is the square root of 4 equal to 2 plus 4 plus negative 4 would be 0. Does 2 equal 2 plus 0? Yes, it does. So both solutions work. We have two answers. Okay, those are fun ones. All right, next, how do we solve this problem? When we have exponential values, what we want to do is get common bases here. The common base we can do with 2 is just 2. So what's 16? You didn't know. 2 to the 4th power is 16. So we can change this to 2 to the 4th power to the x minus 1 power. Now that we have common bases, they cancel out, and we just get left with the equation of x plus 4 equals 4 times x minus 1. All right, so we can distribute x plus 4 equals 4x minus 4. Let's go ahead and move this 4 over here to become 8 and minus that x over to become 3x. And then we can divide. X would have to be 8/3. Not too bad. Okay, next, what we want to do here is to find the expression here. So what we want to do, each one of these exponential equations is always like the common number, the starting number, times the percentage rate to an x power. So easiest one to figure out is a. And if we ever look at 0, a would be that number there. So basically when x equals 0, this is our a, and that would be 3. The next thing we're going to do is, okay, to find out b, we got to figure out how do we multiply. So how do we go from 3 to 6? We times by 2. How do we go from 6 to 12? Times by 2. Technically, if we go from 3/2 to 3, we times by 2. Each times we're timesing by 2, so there's the answer. It'd be 3 times 2 to the x power. Okay, next, got the same problem here, just it's story problem. All right, there's 150 deer in particular forest. If the population is increasing at a rate of 7% per year, write an exponential growth function here. So what do we start with, and then what percent are we multiplying by? So we are starting with 150, and then what percent? We're not multiplying by 7%. We are to go through, but technically we are multiplying by 1.07. That way there's a growth. Any number that shows a growth has to be bigger than 1. So there we go. All right, to find inverses of exponential functions. So we can go through and switch our x or y's around. We get x equals 5/9 to the y power. Now it might be easier to say 5/9 to the y power equals x and try to go through and figure out to get the y by itself. Remember, we can use our loop and swoop method. So this would be log base 5/9 to the x power equals y. And there is our inverse function. Now that we got it by itself, we can say that the y inverse is the log base 5/9 of x. Kind of weird, but just kind of remembering the loop and swoop cancels out. All right, so we're going to use that loop and swoop to help us out here. If we have this log base 3 of 4x plus 11 equals -2, we can loop and swoop to set up our equation of 3 to the -2 power equals 4x plus 11. All right, 3 to the -2 power, that's 1/9. All right, so if we subtract 1/9 minus 11, oh God, that's going to be low. That would be -98/9. And then if we divide that by 4, does 98 divide by 4? I don't think it does. Yeah, I'm seeing that. Okay, that becomes -49/18. There we go. Not the best one, but probably comes out nice. All right, solving quadratics. So this kind of recapping a lot of things we've done a different way. This one's actually going to come out nice. So if we solve a quadratic, we need to set it equal 0. So we're going to -15 over and go through. First thing we want to do is, can we factor it? What two numbers can we multiply together to get -15, add together to get -2? All right, so that would be positive or -5 and +3. So we'd have an x minus 5 and an x plus 3. And then to solve it, what we want to do is just set each one of these equal to 0, or just name the opposites. We get x equals +5 and x equals -3 as our two solutions. All right, now when we solve by completing the square, what we do here is we go through and we get the x's by itself. Well, we're going to move the 13 over. We get x squared minus 6x, and then remember we put a plus blank equals -13. And then we got to put a plus blank as well. All right, to find this number that goes in the blank, we're going to take the middle number, which is b, divided by 2, and square it. So -6 divided by 2 is -3. -3 squared is 9. So we're going to put a +9 on both sides. So what ends up happening here, this becomes a -4, but we get x. The middle number stays this, middle symbol stays the same, so it'd be minus, and then we just take the middle number cut in half, 3. So this expression here becomes x minus 3 squared. Now, if we want to get the x minus 3 alone, we just need to take the square root of the other side. And the square root of -4 is 2i. It's an imaginary solution. And anytime we take the square root, we have to remember a plus or minus symbol. So it's plus or minus 2i. And so finally, the answer, we would add the 3 over, and we put that in front, be 3 plus or minus 2i. So that was one way we learned how to solve. The other way we learned how to solve was using the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so this case, here we go, we got x equals, if b is already negative, it's going to turn positive, plus or minus the square root of b squared minus 4 times a is 1 and c is 28. All over 2 times a is 1. Okay, so we got 10 plus or minus the square root of, that'd be 100 minus 4 times 28. What is that? 100 minus 4 times 28, that's -12. And 2. All right, the square root of -12 would be an imaginary number here. If we were going to break down the 12, that would be 4 times 3, and that's 2 times 2. So it would be 2i radical 3. And then all we need to do here is to see, can we divide 10 and 2 by 2 as well? Can we reduce this? And we can. So 10 divided by 2 is 5. 2i divided by 2 is just 1i. And the radical 3 we leave alone. So it would be 5 plus or minus I radical 3. All right. right, hey, another problem with the inverse. So hopefully you guys see right now, inverses, no matter what section, all we got to do is switch the x and the y's around. So this would be x equals 17 minus 3y. We're going to go ahead and get the y by itself. So we minus 17 over equals negative 3y. And then we would divide by negative 3. So if you have x minus 17 divided by negative 3, that's pretty good right there. Easier thing to do though is, or one thing to be aware of, if you divide by negative 3, what you can do is actually, if you divide by positive 3, if you switch the fraction or switch the subtraction around, 17 minus x, it would be the same thing. So just be aware your test will be multiple choice, and so you guys can go through those things and kind of be, have to look for that. All right, now switching gears to the next chapter, we got some SOHCAHTOA stuff. All right, so SOHCAHTOA, here we go, some trig. SOHCAHTOA. All right, when the sun shines at a 42-degree angle with the ground, so that's 42 degrees right here, Manuel casts a shadow that's 100 inches long. How tall is Manuel? Okay, so here's Manuel. We want to know his height. Okay, so if we look at this, we're trying to find the opposite. We have the adjacent, so that is a TOA problem. So we'd say the tangent of 42 is equal to, well, we don't know how tall he is, x over 100. All right, if x is up high, we multiply. So we got 100 times tangent of 42. And we're going to type that into the calculator. Just make sure that you're in degree mode. All right, so 100 times tan 42, just typing it into a calculator, I get 90.04. So we can pretty much say he is 90 inches tall. Is that pretty tall? I think that is very tall. Manuel, you're a tall man. All right, next, what's the sine of 240? Okay, so we're going to look at the unit circle. Take a peek over it. Sine is a y, so we look over at 240. 240, it is negative 1/2 negative radical 3 over 2. So the y value is negative radical 3 over 2. Cosine is the x. We look at 180. 180 is negative 1, 0. So cosine is negative 1. Hopefully not too bad. You guys can use your unit circle as a reference. Should be all right on the test. All right, next. Find the following angle measurement. Select all that apply. Oh, I didn't put a list here. So what I want you guys to do is tell me the positive and negative versions of this angle here. So remember, this is 0 degrees and we work our way around, or we can go backwards. So clearly this is negative 70 degrees would be the negative answer. The positive one here, you can see we go 90, 180, 270, plus 20 degrees more, 290 degrees. The one thing about these two answers is that there should always be 360 degrees apart. So from 290 to negative 70, there's a difference of 360. That's another easy way to tell. Okay, next problem is the same thing, just not as a picture. An angle has a reference angle 30 degrees, and its terminal side lies in quadrant 2. Here's quadrant 2. So we got a 30-degree angle coming off here. What are the possible positive measures and negative measures? Okay. So if we're starting here in 0, working our way over, we have 90 plus 30. Okay, so that's 120 degrees. Or if we're working backwards here, we got 90, 180, and then we'd have to subtract 60 more. That'd be negative 240. Another thing you could do is if you figure out your positive, just subtract 360. That's your answer. Okay. Next, we're going to look at some conic sections. So these are always sections that you want to go back, maybe look up your notes, and I might have to go back and see some of those too, because the formulas are pretty crazy. All right, but write the equation in vertex form, the parabola that passes through. Okay, so parabola is y equals a times x minus h squared plus k. Well, we need to find a, h, and k. Well, they tell us the vertex is at 2, negative 4. There's our h and k, but we don't know what a is. We can use our x and y values to figure out that. So if y is 12, we don't know a, x is 0, minus h is 2 squared, plus k is negative 4. We can solve for a. So 12 equals, okay, 0 minus 2 is negative 2. Negative 2 squared is 4. So this becomes 4a and then minus 4. All right, we can add that 4 over, so that's 16 equals 4a. All right, a would have to equal 16 divided by 4 is 4. So the answer here would be y equals a is 4, x minus h is 2 squared, and then plus k is minus 4. Okay, next, all right, write the equation. Well, we know this is h and k, but how do we get a? So this is where I would say you definitely want to look at some of your notes. So I'm going to pull up my notes here and go through, see the formula. And if I write it down on here, you should definitely write it on your review packet. If the vertex is at 0, okay, so we know the vertex, the directrix is y equals, here we go, directrix is y equals k minus 1 over 4a. So y equals k minus 1 over 4a. So if we know that the directrix is -1, and we know that our k is 5, we can solve for that a. And the way that we do it, we kind of learned a similar way, but it still works out this way here. We could go through, subtract 5, and we get a -1 over 4a is equal to -6. Now to solve this, I'm going to make this -6 over 1 and cross multiply. So 4a times -6 is -24a. -1 times 1 is -1. So if we divide, a would be 1 over 24. So the answer would be y equals, a is 1 over 24, x minus h is 0. So you can put x minus 0 squared or just x squared, and then plus k is 5. Okay. Moving along here. Okay, next, the theme park has an arch-shaped parabola. All right, so same thing. We know the vertex here, and that we know the equation for the directrix. Okay, so here's our h and our k. K minus 1 over 4a. All right, so if we know k is 30 minus 1 over 4a, we can set this equal to the directrix value of 45. All right, so we get -1 over 4a is equal to, if we subtract 30 from 45, that's 15. We can cross multiply to help solve. Okay, so 4a times 15 is 60, and -1 times 1 is -1, and so a would have to be -160. So our value here, our answer would be y equals, a is 160 or -160, which makes sense because that's going to be an upside down parabola. And then we got x minus h is 0 squared plus k is 30. Okay. Next, let's go through this here. Okay, so let's talk about this problem. We'll do it the long way, and then we can talk about how we can do this the better way, easier way. All right, so if we want to go through and solve this in vertex form, we'll have to complete the square. Now, the first thing I would do here is notice all these numbers can be divided by 3. Divide them by 3. So we got y minus 6, or not 6, that's not when we divide by 3. We get y minus 2x squared plus 12x minus 66 divided by 3 is 22 equals 0. Okay, what we want to do here is we got to move everything over. Let's get the y by itself. We get minus 2x squared plus 12x plus 22. Okay. Next thing we want to do here is let's complete the square. So we got to factor out this 2. That's plus 6, or x squared plus 6x, and then plus blank. We're going to complete the square. And then we got plus 22. Now, to get rid of this plus 2 times the blank, we're going to have to minus 2 times the same blank here, just to keep everything equal. All right, to find the blank, we're going to take this middle number, cut it in half, and square it. So 6 cut in half is 3. 3 squared is 9. That's completing the square. All right. So this becomes 2 times x plus 3 squared. Remember, symbol stays the same in the middle. We cut it in half. And then over here, let's see, this would be 22 minus 18. That would just be 4. Okay, so there's the equation. We can go through looking at our notes here. The vertex is at hk, which, all right, h is -3, k is 4. All right, the focus, okay, we got to look at the formula sheet for the focus here. We can pull that up. Focus is at h, and then comma k plus 1 over 4a. All right, so we definitely know it is at -3. And then we got k, which is 4, plus 1 over 4a is 2. So that's 4 plus 1/8, so that's 4.125. And the directrix is y equals k minus 1 over 4a. So that would be 4 minus 1 over 4 times 2. And that would be y equals, that would be 3.875. Now, wasn't too bad, kind of complicated, but let's talk about how we can make our life easier. If we went on Desmos here, and let me go ahead and pull this up here, just desmos.com. And if we just type in that equation, that's not going to give us all the answers, but it's going to help us narrow it down. And especially since our test is going to be multiple choice, you can really narrow this down. So we got 3y minus 6x squared plus 36x minus 66 equals 0. All right, we can click. Did I have 3? Oh, you know, I don't know what I did wrong, but okay, I don't have my work. Okay, so we got 3, 4 is the vertex, and then we can see the other thing. We would have had 3, and then focus would have been in the same spot, and the directrix would have been. I don't know why I have. If I move that over, that'd be a positive. Factor no. Oh, here's my problem. I didn't change that symbol. I probably had a minus. That's and that little negative sign. Oh well. I see the mistake now. Okay, circles, same thing. So complete the square. What we could do here is, this is technically the work we should do. Put the x's together. So we got x squared plus 6x. We'll put a plus blank. And then put our y's here. Y squared minus 10y plus blank. And then let's move the 2 over. 2. And then to keep things even, we'll put a plus blank here and another plus blank. All right, so what goes in this blank? We take 6 cut in half is 3, 3 squared is 9. We've seen that a couple times. To get this one here, we're going to take -10 cut in half is -5. -5 squared is 25. All right, so we get an x. This would be plus, and then 3 squared. And then y, got a minus in the middle, and then 10 cut in half is 5 squared, and then equals 2 plus 9 is 11. 11 plus 25 is 36. So the center here would be at the opposite, or HK. So the center would be at -3, +5, and the radius is the square root of the number at the end. The square root of 36 is 6. So talk about how to make our life easier again with this Desmos. You can go through and take 1 second here and type in the equation just as is. You don't need to change anything here. We got x squared plus y squared, and then what else? Plus 6x minus 10y minus 2 equals 0. Didn't even move things around. You can see we have a center or circle here. You can probably click on some things. All right, so we can definitely see we set at 3, 5, or not 3, -3, 5. And then we can kind of look. It goes from -3, 11 to -3, 1. That's a distance of 12. 12 cut in half would be 6, radius of 6. We could have just figured that out. Especially this is multiple choice. You don't have to show your work. You get your answer that way. All right, next, we got an ellipse. So you might want to go through and look at the ellipse formulas here. All right. Ellipse formulas are always like x minus h squared over a plus y minus k squared over b squared equals 1. All right, so if the center is at 0, 0, we got x squared, and then we have y squared. And now, okay, if the major axis length is 18, and the major axis is horizontally, so that means it's going to be on the x, what we need to do is to cut it in half and square it. 18 cut in half is 9, 9 squared is 81. All right, the minor axis, if we look over here, is 10, so we're going to cut that in half. That's 5. 5 squared is 25. Equals 1. So there's our answer. Now, if this was vertical, it'd be 81 over here and 25 over there. And we could double check this equation too by plugging our answer into Desmos, see if we got it right. Okay, next. We got a whole lot of problems here. We can find a lot of these answers on Desmos. The focus one, we're going to take our time. Okay. Let's go through this though. Let's find the answers and then we'll use the formula sheet to get the rest. Okay, center, straight up HK. So H is -1, K is 6. All right, vertices. Well, what we can do here is to see, we can take, we're going to skip the foci right now. There's going to be 2 of them. Let's do the vertices. So vertices, if we're going on the major axis, which is on the X, we're going to move to the left and right 6. The square root of 36 is 6. So we're only going to change the X by 6. So if we add 6 to -1, that's 5. If we subtract 6, that's -7. The co-vertices here, I don't think we need to find these here, but all we're going to do is go up and down on the Y, 5. So -1, if we add 5, that's 11. If we subtract 5 from 6, that's 1. All right, the major axis length, if the whole length, if the square root of that is 6, that means we can go up 6, or left 6, right 6, that's 12. And the minor, we already kind of talked about this, is square root of 25 is 5, left 5, right 5 is 10. All right, the foci is what we need to look at the formula sheet for. And so I will let you guys write down any formulas on the test, use it on this packet, whatever you guys want. I'm going to go ahead and pull up my notes from the focus here. Let's circles. 9.4 is the ellipse, or 9.3 is the ellipse. They switched a section around. My notes that were good or is still good. They're just off by 1 number section. All right, so let's see if we can find the formula for the focus. Now, this is a horizontal one. So the formula that we're going to use, I'm going to write this down here, is H plus or minus AE over A times E comma K. All right, and where E is the eccentricity. All right, so this is kind of crazy here. This is going to be H plus or minus AE comma K. All right, so E is equal to the square root of A squared minus B squared over A. Now keep in mind too, if this is a multiple choice test on the thing, you can find these, there's not going to be one where it just has slightly different focal points. You should be able to figure out pretty soon, but this is the math we would have to do if we try to do the one. Let's first figure out A. All right, so it'd be the square root of 36 minus 25. The difference between those is like 11. And we would divide that by the square root of A is 6. All right, and that what comes out to be square root of 11 is 3.3 divided by 6 is about 0.55. All right, so we're going to take H, which are H is -1. We'll do plus or minus A is 6 times 0.55. All right, so this would be 6 times, well, I'm going to times that number by 6. That is 3.31 or 3.32. Okay, so if we took -1 and we added 3.32, we would get a positive 2.32, and then K is 6. And then if we took -1 and subtracted that answer, we'd get -4.32. All right, and keep in mind our focal points are going to be in between there. Kind of tricky, but there we go. All right, next, what's the equation in the graph? This is way easier. So the first thing we want to do here is x minus h squared over a squared, and then y minus k squared over b squared equals 1. All right, let's first find the center. The center here is, and I'm just going to cross here, and then I would say, yep, cross there. Okay, the center, if we split it right down the middle, would be at over 1 up 0. So it'd be x minus 1 squared, and then y minus 0 squared. All right, now let's look at this one here. The major axis on the y, we're going up 1, 2, 3, 4, 5, 6, 7. On the up and down, so 7 squared is 49. And then on the left and right, we're going 1, 2. We're going 2 left and right. 2 squared is 4. So there's your answer there. Not too bad. And we could double check this too by plugging it into Desmos. All right, now when we're looking at this problem here with hyperbolas, we first see that this is a graph that opens up and down, so that's going to be a y minus x minus h squared over a squared and b squared equals 1. All right, so the center of this graph is right here at negative 1, 1. So it'd be y minus 1 squared, or k is 1, or it'd be x plus 1 squared. All right, now, how far is this graph going up and down? And we remember we split it just like how we split the parabola here. All right, we're going up 3 and down 3. So 3 squared is 9. And then how far left and right we go? We go left 4, right 4, that's 16. We can double check that by plugging it into Desmos. Okay, so the big thing with the calculators here, or the next problem is you're going to have a matching problem on your test. You just need to know, like, okay, y equals a times x minus h squared plus k. That's a parabola. All right, x squared plus y squared equals r squared. That is a circle. All right, if you have x squared divided by some number plus y squared divided by a different number equals 1, that is an ellipse. If you have x squared divided by some number minus y squared divided by, it really could be any number, it could be the exact same thing, but if you have the minus sign, that is the hyperbola. All right, so there's chapter 9. Chapter 10 is the last chapter. So matrices here, what we just went over. Okay, a couple of rules about matrices. You cannot just, when you're multiplying, switch the order. Order matters, so it's not A. All right, does P times 2 equal? No. Addition is not the same thing as multiplication. All right, does P plus Q times P equal? No. We could distribute backwards, but it doesn't work out to be P squared. All right, does P plus Q equal Q plus P? Yes. When we're adding, it doesn't matter which way we add. Multiplication we have to be aware of. All right, next, matrix G here. Okay, let's write this out. It represents the video games in a text store. Column 1 lists action. Column 2 represents racing. Row 1 represents beginner. And row 2 represents expert. What does the number in 1, 2? So that's row 1, column 2. So it'd be right here. That'd be 30 beginner racing games. All right, next, if we're subtracting matrices, we just got to be careful of the order A minus B. So we're going to take element A, subtract element B. So 10 minus 6 is 4. Negative 2 minus negative 9, that's 7. 5 minus 11 is negative 6. Keep it going from the next row. Negative 3 minus 1 is negative 4. 0 minus negative 9 would be 0 plus 9, or 9. And then 3 minus negative 3 is 6. There we go. All right. What has to happen for the matrix to not have an inverse? To not have an inverse with A, B, C, and D is that A times D minus C times B would have to equal 0. All right, if they equal 0, if we cross multiply and they're the same number, we can't have an inverse. All right, set up the system of equation. What we need to do, there's the trick. Technically, we're going to take this row, times it by this, and set it to that value. And that would be 2x minus 3y, set it equal to the top value of 14. And the same thing on the bottom here. We got 7 times the first number x plus 10 times the last number y equals the last element here, 150. All you can see is basically call this x, call that y, set it up, set it equal to that. It's easy. All right, what is the solution of this matrix here? So if we want to go ahead and solve this problem, what we need to do is to take xy would equal the inverse of the first matrix times by 2372, the other matrix. All right, and we can actually use this in the calculator. So we can go ahead and I'm going to pull up Desmos matrix calculator. Okay. I'm going to make 2 matrices here. Once it pops up, a new matrix here. We got matrix A, which is 6, 5, negative 1, 10. Make another matrix here, and I'm going to make it only have one column here, 23 and 72. Okay. So what we're going to do is we're going to take the matrix A, take its inverse, and then we're going to multiply it by matrix B. And there we go. It does all the hard work for us. We solve it here. And so xy would equal -2, 7. Okay. One more problem, and I think we will be all done. Okay, so we got a company that makes golf clubs for adults and juniors. Last month they spent $20,500 on labor. Next they spent $29,250 on materials. All right, we're going to find. So if we wanted to go through and set this up, we can say that $30 and $40, which is their x times their y, would equal labor costs here would be $20,500. And then the 35 for the materials for the adults and 60 for the materials for the juniors for the y will equal $29,250. All right, so we can set up a system of equations by saying, okay, 30x plus 40y equals 20,500. 35x plus 60y equals 29,250. Or we can go through and solve by using matrices. We can say that the inverse of 30, 40, 35, 60, the inverse of it, if we want to get rid of this, get the x by y by itself, we get to times that inverse by the price matrix. I like to use the matrices because once we program in it, it's super easy. All right, so we'll take out the Desmos here. All right, and you know what? We can just go through and program this. This will be 30. It's going to change it automatically for us. That's amazing here. 40, 35, 60. We got 20,500. And then 29,250. Boom, there we go. We got 150,400. So x, y, 150,400. All right, so that means X is the adult club, so we got 150 adult, and Y is the junior, so we got 400 junior. All right, guys, I know that was quick, but maybe you guys can pause the video, go back and watch anytime. You can see if you have any trouble, ask. Make sure you know how to spell my last name, and I will see you guys for your final exam. Have a good one.